find the approximate value of f of 2.01 where f of x is equal to 4x square plus 5x plus 2. We are going to do this. We know how to find this by giving the value to x. But here approximate value and using differentials we can easily find this approximate value. Here f of x is 4x square plus 5x plus 2. We need to find the approximate value of f of 2.01. What we have to do for using differential, you have to give the value 2 to x. We need to choose a value for x and a value for delta x so that x plus delta x is equal to 2.01. Take the whole number part value to x and the decimal part value to delta x. Therefore, x is 2 and delta x is equal to 0.01. And you have to start with let y is equal to f of x. Then just like the previous questions, y plus delta y is equal to f of x plus delta x. Now, y is f of x, we know that. Therefore, I am giving y as f of x plus delta y is equal to f of x plus delta x. Next, f of 2 plus delta y is equal to f of 2.01. Let it be equation number 1. Therefore, for finding the approximate value of f of 2.01, it is enough to find the approximate value of delta y. And we know that we cannot find delta y directly, we can find only the value for y is dy by dx into delta x. Our function y is, our f of x is 4x square plus 5x plus 2. Therefore, dy by dx is 8x plus 5 and you have to give the value for x here when x is equal to 2 into delta x, and we know that the value for delta x is 0.01. When we are giving the value x is equal to 2 for 8x plus 5, it will become 21. 21 into 0.01, then dy is equal to 0.21. And we know that dy is a good approximation. Delta y is approximately equal to 0.21. Then one more thing, look from equation number 1. F of 2.01 is f of 2 plus delta y. Therefore, we need to find f of 2 also. Next, we are going to find f of is equal to 4 into 2 square plus 5 into 2 plus 2. That is, it is, okay, look, 4 into 4, 16 plus 10 plus 2. It is 28. Therefore, from 1, the approximate value for f of 2.01 is 28.21. This is the answer. Now, we are going to next question. Next question is find the approximate value of f of 5.001 where f of x is equal to x cubed minus 7x square plus 15. Okay, answer. Here f of x is equal to x cubed minus 7x square plus 50. We need to find the approximate value of f. Approximate value of f of 5.001. Therefore, take that whole number part for x and 0.001 for delta x. I am taking x as 5 and delta x are 0.001. Start with y is equal to f of x. Then just like previous problems, y plus delta y is equal to f of x plus delta x. That is, y is f of x plus delta y is equal to f of x plus delta x. Now what I am going to do is giving the value for x and delta x. Then we know that x is 5, therefore this will become f of 5 plus delta y is equal to f of 5.001. That will be equation number 1. Now we are going to find f of 5. F of 5 is 5 cube minus 7 into 5 square plus 15. And you are keep getting values minus 35. Next, we cannot find delta y directly, we can find only dy. And dy we can find using the formula dy by dx into delta x equal to, then derivative is, it is x cube minus 7x square, therefore 3x square minus 14x. This is the derivative into delta x is 0.001. And we need to give the value x is equal to 5 for this. That is, this is equal to 3 into 5 square minus 14 into 5 into 0.001. That is, this is 25 into 75 minus 70 into 0.001. Value is, this is equal to 0.005. Therefore, we know that the approximate value for delta y is 0.005. From equation 1, the approximate value for f of 5.001 is approximately equal, that is approximate value is minus 35 plus 0.005. That value is, that is approximately equal to minus 34.995. Therefore, this is the answer. Our next question is, find the approximate change in the volume V of a cube of side x meters caused by increasing the side by 1%. Find the approximate change in the volume V of a cube of side x meters caused by increasing the side by 1%. We have delta x as 1% of x. We need to find delta V. Delta x is equal to 1% of x. That is equal to 1 by 100 into x. That is equal to 0.01x. We need to find the change in approximate change in the volume of the cube. And we know that volume of a cube is V is equal to x cube. And for finding delta V, we can find only dV. Therefore, we can find dV by using the formula dV by dx into delta x. Then dV by dx is equal to 3x square into delta x is 0.01x. Therefore, answer is 0.03 x cube meter cube. That is, delta V approximately equal to 0.03 x cube meter cube. That is the approximate change. That is the approximate change in volume is 0.03 x cube meter cube. The next question is, find the approximate change in the surface area of a cube of side x meters caused by decreasing the side by 1%. Find the approximate change in the surface area of a cube of side x meters caused by decreasing the side by 1%. Answer. We know that for the cube surface area is 6x square if x is the side. And here it is given that our side is decreasing for 1%. Therefore, this is minus 0.01x. We need to find the approximate change in surface area. For that, we can find only ds using the formula ds by dx into delta x. Ds by dx is 12x into delta x is minus 0.01x. Therefore, answer is minus 0.12x square meter square. Therefore, the approximate value for delta, that is delta s, is approximate value for the surface area of the cube is minus 0.12x square meter square. Minus is indicating that it is also decreasing. Next question is question number 6 from the same exercise. If the radius of a sphere is measured as 7 meter with an error of 0.02 meter, then find the approximate error in calculating its volume. Here also we have to find delta V and we have delta R. Delta R is 0.02 meter. And for a sphere volume, we know that it is 4 by 3 pi r cube. Therefore, we have delta R, we need to find delta V. Volume of the sphere is 4 by 3 pi r cube. Delta R is 0.02 meter. We can have to find delta V, but we can find only dV using the formula dV by dr into delta R. This is 4 pi r square into 0.02 meter, and we are getting it as 0.08 pi r square meter cube. Now we have to find out the change when r is equal to 7 meters. Therefore, when radius is equal to 7 meters, dV is equal to 0.08 pi into 7 square, 40. Therefore, delta V is approximately equal to 3.92 pi meter cube. Next section from the chapter applications of derivatives is maxima and minimum. First we are going to do some problems like look the question, find the maximum and minimum values, if any, of the following functions. Using mind calculation, you have to find out the maximum or the minimum value of the following functions if they are existing. Okay. Question number 1 is f of x is equal to 2x minus 1 the whole square plus 3. And here we have to find out maximum and minimum. Look, the first term is a perfect square, and we know that for this perfect square, the minimum value is 0 and we cannot say anything about the maximum value. It is increasing. Therefore, we have for the first term, we have a minimum value. Minimum value of a perfect square is 0. Therefore, we can define only the minimum value for f of x. Minimum value is equal to, for this first term, the minimum value is 0 plus second term 3. Therefore, 3 is the minimum value of this function and we cannot find any maximum value for this function because the square function, first term is a square, it is increasing. Second question is f of x is equal to 9x square plus 12x plus 2. In this form, we cannot say anything, which is the maximum value obtained by this function, which is the minimum value. But if we are trying to write this in the form of a perfect square, or job is easy, that is, we are going to follow the method of completing the squares. We know that in this form we cannot say anything. We know that 9x square is the square of 3x the whole square plus, then middle term 12x. I am using the expansion of a plus b the whole square. First term is a square plus second term is 2ab. Therefore 2 into a is 3x. Therefore for getting 12x, b should be 2. Look, 4 into 3x, we are getting 12x. Therefore, b is 2. Therefore, I am going to add its square, 2 square. And for balancing, I am going to subtracting it. And plus 2 from the question. This is the process of completing the squares. Then look, these from 3x the whole square to 2 square. This is the expansion of 3x plus 2 the whole square minus, then look, the remaining is minus 4, minus 2 square plus 2. Minus 4 plus 2, you are getting 3x plus 2 the whole square minus 2. Now our f of x is 3x plus 2 the whole square minus 2. Just like the previous question, the first term is a perfect square. It has only minimum value, 0. We cannot find its maximum value. Therefore, for this function also, only minimum value of f of x is, minimum value of first term is 0, then minus 2 is there. Therefore, the minimum value of this function is minus 2. And we cannot find maximum value because it is the square term. Square is increasing. Therefore, no maximum value. Next question is f of x is equal to minus of x minus 1 the whole square plus 10. We need to find its maximum value and minimum value if they are existing. Look, the first term is minus of a perfect square. Because of the presence of this minus symbol, actually its value is decreasing. That is, 0 is the maximum value of this term because of the presence of this negative. We know that x minus 1 the whole square is always 0 or positive. But because of the presence of this negative symbol, it is 0 or a negative quantity. Therefore, 0 is the maximum value of this function. Therefore, maximum value of f of x is equal to 0 plus 10 equal to 10 and no minimum because it is decreasing. We cannot say anything about the minimum value of this function. Question number 4 is f of x is equal to x cube plus 1. Only this much. The first term is a perfect cube and we know that for positive numbers it is positive and for negative numbers it is negative. And we cannot say anything about the maximum and minimum value of this function. Therefore, answer is no maximum value, no minimum value. Next, question number 5 is f of x is equal to modulus x plus 3 minus 1. And look, here we need to write its maximum and minimum value. And the first thing is a modulus function. We know that modulus function for its value is always positive or 0. Therefore, 0 is the minimum value of the first term. Therefore, for this f of x only minimum is existing and minimum value is 0 minus 1 where 0 is the minimum value of this modulus function. Therefore, minus 1 is the minimum value of this function and no maximum value. Then question number 6. F of x is equal to minus modulus x plus 1 plus 3. minus modulus x plus 1 plus 3. Look, here also the same thing. We know that modulus is always 0 or positive. But because of the presence of this minus symbol, it is either 0 or a negative quantity. Therefore, 0 is the maximum value of the first term. Therefore, for f of x, only maximum value of f of x is 0 plus 3, 3 and no minimum value. Next question number 7. F of x is equal to sine 2x plus 5. And first term is sine of 2x. And we know that the maximum value taken by sine is 1 and the minimum value taken by sine is minus 1. Therefore, maximum value of f of x is 1 plus 5, 6 and minimum value of f of x is minus 1 plus 5 equal to 4. Question number 8. F of x is equal to modulus sine 4x plus 3. And look, here is a modulus function and here we can, for the terms inside that modulus symbol is sine 4x and 3. And we know that the minimum value for sine 4x is minus 1 and maximum value for sine 4x is plus 1. Therefore, maximum value for f of x is modulus 1 plus 3 is equal to 4 and minimum value of f of x is equal to minus 1. The minimum value for sine 4x plus 3 equal to, it is positive 2, modulus of positive 2, it is 2. Now question number 9. F of x is equal to x plus 1 where x belongs to open 0 1. Question number 9. F of x is equal to x plus 1 where x belongs to open 0 1. Here we cannot say anything about its maximum and minimum value because x belongs to open interval 0 1. We cannot say anything about which is the least value taken by x, which is the greatest value taken by x, that we cannot say. Therefore, here no maximum, no minimum. Then ask question number 10. Take f of x is equal to x plus 1 where x belongs to closed 0 1. Here x belongs to closed value for f of x. Maximum value for f of x is equal to maximum value taken by x is 1. Then 1 plus 1 equal to 2 and minimum value of f of x is equal to this 0 is the minimum value taken by x plus 1, that is equal to 1.